Understanding and Configuring Dial Peers Part 2. I'm going to pick up in this nugget right where we left off in the previous one, but just to bring us all back up to speed, in the previous nugget we talked about call legs, this concept or this theory of how we create the individual links on our network to bridge legacy voice networks to voice over IP and voice over IP to voice over IP networks and all these kind of things. Each link will need a call leg. In the last nugget, we also set up a scenario where we set up and configured POTS and voice over IP dial peers. I'm going to go back to that scenario again because we're not done with it yet. We set up the link for the analog devices using POTS dial peers. We did the link between two routers using voice over IP dial peers, but we still haven't set up the PSTN connection, the digital connection, and for that we're going to need to rely on our dial peer wildcards, which we did get into in the previous nugget, but I haven't given you enough examples of those so that you can really see their usefulness, especially when we're connecting to the PSTN. So let's pick up right there and get going. So here's our scenario that we set up last time. And just to review where we are at this point is we have gone through and set up the analog connections, the POTS dial peers, to both of these phones to assign them 3301 and 3302. Then we went down here on the CME router and set up a voice over IP dial peer to 330 dot. That was our destination pattern. To say anything with 330, send it up to 10.1.1.2. And we went to this router and set up a voice over IP dial peer to say anything with 10 dot dot, send it down here to this router. And that we placed calls. We were testing communication between these two routers, and they were communicating just fine. So now what I'd like to do is expound on that and get into the PSTN connection. Now before I do this, I want to make sure I mention that it is actually outside the scope of the CCNA Voice certification exam to talk about the configuration of the digital voice port, meaning the physical configuration, setting this up and connecting to the PSTN. But ironically, it is in the scope of the CCNA Voice port exam to talk about the dial peers and set up the dial peers to connect to the PSTN using that digital voice port. So that's a little wacky for me. So what I'd like to do is go a little outside the scope and show you the configuration of this voice port and the configuration of these dial peers. It'll give you a broader scope, but I'll make sure I mention that as I'm configuring this, keep in mind that you won't see some of this configuration on the exam. So what I'm going to do is go into my legacy voice router up here, and I'm going to do a show voice port summary. I did this last time to show that we have the FXS ports, which are connected to these analog phones up here. And I noticed that I don't see, even though it's a voice port, I don't see this T1 interface. And the reason for that is because this, if you remember, is a VWIC card. It is able to connect to either a voice network or a data network. A WAN interface card is what it could be. And since I haven't told the router what kind of network it's connecting to, it doesn't show up as a voice port because it doesn't know if it's going to be one. So let me do this. I'm going to go into my router and do a show run. Let's take a look at the running configuration. We'll scroll down a little bit. There's our DHCP pools we set up. And right here is my T1 controller. That represents, you see voice T1 1/0. That is what represents this voice card, this VWIC card, and it shows some framing and line coding, which are actually wrong. I need to change those. That's the default to connect to the service provider. But that is what we'll be using to connect to the PSTN carrier. So I need to go into global config mode. Not, you love it when my hand is in the wrong place and I type in something like that. Config T, and I'm going to go into controller T1 1/0. Now this is the part that is not on the CCNA Voice, is configuring this as a voice port. But it's really easy. I'm going to first set the framing and line coding to say this is the type of network I'm connecting to. In the United States of America, and you might remember this from the historic voice section, we use the framing of ESF. You can see it's either superframe or extended superframe. We're using ESF, extended superframe. And line coding, we're setting to B8ZS. That is what we use. Again, the carrier will specify that and say, these are the framing and the line coding that you need to specify to connect to us. So we'll type in ESF and B8ZS. Then I need to set up how many voice channels I will have connected to the PSTN. Now the command I use to do this will dictate whether it's a CAS or CCS configuration. Remember, this is robbed bit signaling. I'm stealing bits for my voice signaling. And this is, I'm dedicating one channel for my signaling, also known as ISDN PRI. So if I'm using CAS, I'm going to use the command ds0 group, which I'll show you in just a moment. If I'm using CCS to connect to the PSTN, I'm going to use PRI group. Now let me show you that. So I'm going to go in here and type in, if I'm using CAS, ds0 group, oops, and I'm going to type in the group number, we'll say is just 5. You can pick a number. This is just what identifies this group of ds0 building blocks that you're going to use. And remember, on T1, it's comprised of 24 ds0s. Again, I'm pulling all this from those historic voice nuggets. So I'm going to say ds0 group is 5, and it's going to use time slots. We'll say we bought a full T1 to the PSTN. If we bought half a T1, we would use half these channels. But I'm going to say time slots 1 through 24. So I'm going to use all 24 channels. It's a full T1. If I bought half a T1, it would be 1 through 12. And then I'm going to say the type of signaling. I'll say type is, and then I have a question mark. Now this is going to match the other side. The PSTN carrier will most likely either use FXO loop start or FXO ground start. Remember, FXO, they're providing the signaling to me. But if it's a PBX system that I'm connecting to over here, we could use ENM, we could use FXS. This is all just to match the other side. So I'm going to type in this case, I'll use FXO loop start. We'll say the PSTN carrier specified that I'm going to use this kind of signaling on my T1 line. As soon as I do that and hit enter, the router now knows I am going to be using this for voice port connectivity. So much so that, watch this, I'm going to go back here and do a show voice port summary. Oh, whoop, not dash. Voice port summary. And hit enter. And where I originally had 2 FXS ports as my voice ports, look at this. The router is suddenly like, aha! I now have 24 different it sees them as FXO loop start ports, all considered port 1/0, that's our T1, :5. That's our DS0 group number that I picked right here. When I said DS0 group 5, it said, okay, well, I'll make this :5. And inside of here, I see all these different channels. Channel 1, 2, 3, 4, all the way up to 24. These are all the individual DS0s that I'm going to use, and now it's seeing those all as valid voice T1 ports. Now, if I was using CCS, common channel signaling, which is actually more common to connect to the PSTN carrier, I would have done the same exact thing. I just would have used PRI group instead of DS0 group. And I would have said the time slots are, 1 through 24. It's the same thing. It's just the router now knows I'm using PRI, or what's also called CCS signaling, to connect to the other side. And I've got a dedicated signaling channel. But we'll keep it DS0 for now, because that is now bringing up the voice port that is connected to the PSTN. I want to emphasize again, that configuration that I just showed you is part of CCVP. That's the digital voice port config. Now we'll get into the stuff that's on the CCNA Voice, and that's configuring the dial peers so that they are able to connect to the PSTN. Now what I'm about to show you is a sample plan for North American dialing. And that's within the United States. But you can simply modify these examples to fit whatever dialing plan you have in your area. So let's say we've got our connection now. We've got it configured to the PSTN. Our T1 line is physically set up. That's what we did with the DS0 group. Now we need to create some dial peers for it. Let's talk about the destination patterns. The destination patterns are going to be using the wildcards that we discussed in the previous nugget extensively. Now I mentioned that in the last nugget, if we do a destination pattern 9T as our dialing plan, remember T was any number of digits, it's extremely, I called it a lazy PSTN dialing plan. It's extremely ineffective because with the T, the router never really knows when you're done dialing. If you dial 9, it matches the T, because 9 and then 0 digits after that will match. You dial 911, it matches that. You dial 9159612, whatever number of digits after it, and it matches because it matches anything from 0 to 32 digits. So the problem is the router never knows if you're done dialing if you use a 9T. So what you want to do instead is manually recreate the PSTN dial plan. Sounds like a lot of work, but it's not that bad if you use wildcards effectively. For example, if you are in a 7-digit dialing area in North America, you could do something like this. Destination pattern 2 through 9. Remember the range command. So if the first digit is anything from 2 through 9, then ... That's the first 3 digits. Then ... I know I'm going into my WAN link there. That's the last 4 digits. This is a 7-digit number. So just like that, we've got one destination pattern that is used for 7-digit dialing. Now, if you're in a 10-digit dialing area, you could do something like that, like this. Do a 2 through 9 bracket ... And if in North America, there's 7-digit and there's 10-digit dialing. I live in a 10-digit dialing area, meaning I have to dial 10 digits to reach any phone. So I'll do 2 through 9 ... bracket 2 through 9 bracket ... Now this one's not really necessary. It's just kind of you feel fancy because this represents the local area code. This represents the 7-digit prefix. Then we can do ... to match the final 4 digits. So for example, a number that I might dial in my area code is 602-555-1212. The 602 right here matches the first 3. It'll always be 2 through 9 for the first digit because 1 or 0, 1 is used for long distance, 0 is used for the operator as the first digit, are not going to be used. And it will always be 2 through 9 for this third digit, the local prefix. So first 3 digits, 2 through 9 ... That matches 602. And then the next 3 digits, that's 2 through 9 ... matches the prefix. Then the last 4 digits can be anything. 1212 matches these last 4 dots right here. So that would be the local 10-digit dialing, within the area. I'm in Arizona, so we have 602, we have 480 as a local area code, we have 623. Any of these are considered local area code, as in there's no toll charges. Now, what about long distance? Well, long distance could use the destination pattern 1 and then copy and paste. Same exact thing. 1 and then 2 through 9, and then 2 through 9 is the third one. It's the same exact plan, but this is all long distance in North America. Starts with 1 and goes to here. Now what about international? Well, international is a little more difficult because now you start getting into patterns of other countries. So usually it's safe to do one of these numbers. 011 T. That's where the T wildcard can come into play. And you can either inform your users to say, hey, if you dial international, you want to follow it up with a pound symbol, or it's kind of strange, but users are apt to wait much longer for an international call to go through because there's the perception of it's going through satellites, it's going overseas, it's going to take a long time to set this call up. So, that would be an easy way to get an international dial plan, or you can manually start creating other countries' dial plans using this kind of system. Now, one more thing. In North America, we have service numbers. There's many of them out there. Anything with a digit and 11 would match that. So you might have destination pattern, and we could do like a 4, a 6, or a 9, bracket 11. Now, those are just some of the service numbers, like 911, 411 is information, 911 is emergency, 611 is the local police department's non-emergency situations, and there's other 11 numbers that you can just include in this little bracket, but that would give you a pattern for the dial plan, for the local PSTN service numbers is what those are called. So you can see in 4 patterns, I have successfully created essentially a full North American PSTN numbering plan. Now, how would I implement that on a router? Well, I would get into my router, sitting on my legacy voice router, and we just set up the T1 line, the DS0 group, so I have all of Remember when I did the show voice port summary right here, I have 1/0:5 is the port number. So when I set up my dial peers, I could do dial peer, we'll do voice, and we'll say 9, which is, well, I didn't include 9 in my examples. 9 is the outside dialing code, right? So I could do where'd my prompt go? A 9 for an outside dial code, and then, well, let me just do this. It'll be a little easier to paste in there. I'll say I'm doing 10-digit dialing. Do a copy and a paste. There's my 10-digit dialing. Oh, wait a second. Oh, what am I doing? Jeremy, sometimes I'm getting way ahead of myself. I did dial peer voice. I'm doing a tag number. I'm thinking of destination pattern already. This is the tag. So I'll say, for 10-digit dialing, we'll do 9 that's the tag. And we'll do this as a POTS dial peer, because even though we're using the T1 line, we're going over a POTS network. Now we can do the destination pattern. My mind is five steps ahead. Destination pattern, and then this will be my destination pattern. Enter. That'll be the pattern that I match for 10-digit dialing. And I can even put a description. I'll do description 10-digit dialing under this dial peer. And then I'll send it out port. And which port was it? Scroll back up. 1/0:5. Paste that in there. Port 1/0:5. So that'll be my my T1 line. Exit out. Hit the up arrow, create a second dial peer. Let's do dial peer voice 9-1. And we'll say the destination pattern for this guy will be, paste that in there, and this will be the 1. This is long distance, so I'll do description, long distance dialing, and also going out port 1/0:5. See how this is working? You can point 50,000 dial peers, if you want to create that many, to the same port. The router doesn't care. It's just saying when I match this number, I will send it here. So now when I go back here, do a show dial peer voice summary, I can look, and I'm creating slowly but surely, it's kind of continued cutting off right there, but I'm creating slowly but surely this dial plan for the PSTN that's all sending it out port 1/0:5. Now, it shows the status is down, and the only reason why is because as of right now, I don't have this T1 line plugged into anything. I don't actually have a voice T1 at my location here, but as soon as I did, as soon as I connected that, these would show a status is up because they are actively receiving a signal. So that is how we can manually create. Now, I would do the same thing for all the other patterns that I defined right here. That is how we can manually create a PSTN dial plan. More on that PSTN dialing in a little bit, because there is more that we'd have to put in there to set that up. For example, we don't want to send the 9 to the PSTN carrier, right? When people dial a 9 for outside access. So we'll have to get more into digit manipulation, which is coming up in the end of this nugget and in the next nugget, before we can appropriately and accurately create a PSTN dialing plan. So the last thing I want to talk about in this nugget is understanding inbound and outbound matching. Again, remember I said it was huge, colossal dial peer concept. This is huge and colossal for understanding how the dial peers work. For instance, if there's an overlap. On outbound dial peers, like when I have let's get a scenario here. I've got a router connected to a phone on an FXS port, and it is dialing outbound to, we'll say, the PSTN on an FXO port. If we've got dial peers where multiple ones are pointing different destination, the most specific destination pattern will always win. So, for example, I've got dial peer 1 voice over IP. Destination pattern is 555 1 through 3 as the 4th digit right here, and then any 3 digits after that. Dial peer voice 2 voice over IP, and you can see it's going to 1 session target. These are all going different destinations, different session targets. I've got dial peer 2, which is 5551 ... which goes to a different IP address, and then this one right here, 5551. And then nothing, it's just a exact match. If somebody dials 5551, it's going to this one. So the question is, someone picks up the phone and dials 555, let's say, what's a good example? 555-1234. Which of these is it going to match? In this case, looking at this list, most specific destination pattern always wins. It's going to be, drum roll please, this one. You might go, whoa, wait a sec. You dialed 555-1234, which it seems like would be one of these two. Well, yes, but the way dial peers work is as soon as it has a specific match, it's done collecting digits. This is an overlapping dial plan where things go bad because, in all honesty, this dial pair right here would never be used, ever. Ever. Because as soon as somebody dialed 5551, immediately the router goes, oh, got a match, you're done. They would dial this and they'd hear the little beep, but the router would not collect those digits. It would be actively routing the call to this destination. Now, it seems like, oh, that's bad. Why would we have that? Well, it's actually good if we have patterns like 911 or 9911, which are going off to emergency numbers. I mean, if we've got overlapping patterns, like for instance, 9, we'll say, bracket 2 through 9, ... I'm just scribbling here, but, this is we'll say our 7-digit dialing. Somebody dials 911, does it match this? Yes, it does. 9. Oh, wait. No, it doesn't. Never mind. Sorry, bad example. But it's good. It's good when we create a dial peer where we say, the destination pattern is 911 or 9911. If there is any other patterns that overlap, and bad example because I didn't put 1 right there as the second digit, but let's say we had 9 ... is one of our patterns, it would be an overlap there. But if it had an exact match, it would say, I don't care about the overlap, I'm routing that needs to get to the PSTN. The bad part of that is when we have a situation like this, we have a problem because you'll never get to these numbers because you have a bad overlap. So in that case, you have a choice. You can either, whatever this goes to, you change, meaning that's a bad number. We can't have that. It overlaps. Or you could follow this up by putting a T, just like that, after that pattern. Then when somebody dials 5551, it would sit there idle because if they dial more digits, it would match this one. Or just after that interdigit timeout we talked about earlier, they just kind of sit there and don't dial any digits. This T matches, remember the match, 0 through 32 digits. So if they don't dial anything more, this matches because it's 0 digits more. So this would end up matching and going through. Or they could dial, remember the shortcut, you could dial 5551 and hit the pound symbol to immediately process the call, and that would work too. But I'm telling you, that's just a headache. Just get rid of this number in that case. So let's say we kill this whole dial pair. It's gone, right? So all we have left are these two. Now somebody dials 555-1234. Now which one does it match? Again, we match this one, and we match this one, 555-1 through 3, because 1, 2, 3, 4 matches that. Which one does it route to? In that case, this one ends up winning because it is the more specific match. It's like a routing table. The routing table on a router always picks the most specific match as where it's going to route to. In the same sense here, this one matches around 3,000 or so numbers, 1, 000 through 1999, 20, same thing. So 3,000 number match here, and this one matches about 1,000 numbers, making this one more specific. The only time this one would match is if somebody dialed 555, maybe 2111 or 3111, in which case it no longer matches either one of these two, or this one since we deleted that guy, this destination pattern, so this one ends up winning. So for outbound dial peer matching, it's always going to be the most specific match, just like we saw in those examples. Now, one of the things that blows people's mind when we first get into it is the idea of inbound dial peer matching, which seems odd. Because everything we've talked about, for instance, when we did destination pattern 3301 on this POTS dial peer, it's like outbound. 3302, outbound. When we're going to 10 ... in our voice over IP dial peer, it's outbound. When we're going to 330 ... It's outbound. Everything we've talked about so far is outbound, but dial peers also have to match inbound. It seems weird at first, but the router needs to receive a dial peer, a call leg, a connection from the other side. So, for example, when we did out to 10 ... and this phone dialed 1005, the router got it and routed it over here. Well, we need some kind of inbound dial peer to receive that. And then, it goes out over here and reaches the destination device. When we dial 3301, it went out right here. Well, we also needed an inbound dial peer to receive it over here. Otherwise, the router wouldn't receive it. When we're going out to the PSTN, we had all these outbound. But what about inbound calls? When we come in from the PSTN, we have to have a dial peer to receive it. So we also have to have this concept of inbound dial peer matching, which I will be the first to admit you forget about. A lot of times you're all outbound, all these things. But you have to have inbound or else some devastating consequences can occur. And I'll talk about those in just a second. So when you initially see the list of how a router matches inbound dial peers, it can be a little overwhelming and confusing. It's not as simple as the outbound dial peers. But what I'm going to do is work through the list with you, and we'll talk about it. It'll be kind of clear when I'm done, but not all the way clear. And then I'm going to show you some examples where we'll clarify all the understanding of that. So let me give you just a miniature scenario up here at the top. See if I can squeeze it in. Say we've got two routers, router 1 and router 2, with a phone attached to each one of them. And the phone on router 1 makes a call to the phone on router 2. You've got the dial peer here, you got outbound right here, then you've got this inbound dial peer right here, and then outbound right here, and so on. So I'm going to focus and just talk about this one, this inbound dial peer. As router 2 receives the call from, we'll say, extension 1000 over here, it's going to be going through this list to match an inbound dial peer. So the first thing it does is it tries to match the dialed number, or DNIS. That's dialed number information. DNIS information to what's known as the incoming called number dial peer configuration command. So if you've got extension 1000 over here and extension 2000 over here, the number that he dials, when he dials 2000, that is considered DNIS, or dialed number information. So it's going to go through to router 2, and router 2 is going to say, okay, under one of my dial peers, do I have the command incoming, well, I don't need to write it. It's right here. Do I have the command incoming called number, and then maybe 2 ... under one of my dial peers, or 2000 under that? Is that there? Well, if not, and we haven't even seen that command yet, that'll be coming up in a little while. But if that command is not there, then it'll say, well, I don't have an incoming match. Done with that. The next thing it's going to do is try to match the caller ID information, known as automatic number identification, or ANI service, using the answer address command. So again, it's going to look under all of its dial peers and say, do I have any command under there that says answer address? And now remember, in this case, it's 1000 calling 2000. So 1000, I know it's microscopic there, 1000 would be the caller ID information. He's the one who's calling the other side. So the router 2 is going to say, do I have any dial peers that have the answer address command under there? Maybe it says answer address 1000 or 1 ... or anything that would be a match to match this caller ID information, because that will now match the incoming dial peer. Now remember, we're looking for an inbound match. A dial peer that we've seen so far in outgoing also matches incoming, so it's going to say, okay, do I have a caller ID information for that? Can I match it using the answer address? The next thing it's going to do is say, well, if that fails, which it did in this case, can I match the caller ID information, which in this case is 1000, using the destination pattern dial peer configuration command? It's going to look and check its dial peers and say, do I have any dial peers that say destination pattern 1 ... If so, that'll be my match. If not, it says, nope, that's not it. It's going to say, okay, well then, can I match an incoming POTS dial peer using the port configuration command? It's going to look and see, did this come in on a specific port? In this case, it didn't. It came across an IP network, so there is no port command, so it'll cross that one out. It says, okay, if no match has been found, if all of these methods fail, and like I said, I know it's a little cloudy right now. It's like, we'll get into all those as I look at some examples. But it says, if none of them match, then I'm going to use dial peer 0. Now, what is dial peer 0? Well, this is the quote-unquote devastating result. Maybe it's not so devastating, but it's a bad result when it's matching an incoming dial peer. Dial peer 0 is one that it just makes up. It says, you know what, I don't have anything that matches you, so I'll just pretend I have a match. And the reason it does that is so that it can have two-way audio, that the call will go through. But the problem is that dial peer 0, you can't configure, you can't modify. It gets no quality of service. So if you have a busy network, you're going to get very poor quality on the call. There's a lot of disadvantage to dial peer 0. So your goal, if you will, is to try and get a match before you reach this final dial peer 0 one. So here's a practical example of inbound dial peer matching that will definitely bring some clarity to those steps that I just discussed, walking through this scenario. We've got an extension 1101 over here that's going to be placing a call to, not shown here, but just drawn in, extension, we'll say 2510. Okay, so he picks up the phone on this side and dials 2510. Those are the dial digits. Now, you notice we have call legs. It's coming in right here, so we're going to need some kind of inbound dial peer match. Then it's going out right here. It's leaving, so we have to have an outbound match here. Then it's being received by router B, and that's going to be another inbound. And then, once again, we're going to be going outbound right here. So in this scenario, here's what the router does. The phone picks up, here's a number, or dial tone, dials the number, 2510. The first thing the router does is say, okay, 2510 just came in. Does this match some incoming called number? Well, looking here, we've got dial peer 1101 POTS, which gives the phone its phone number, 1101, out port 1/0/0. So it comes in and says, nope, I don't see any incoming called number there. It says, does the ANI or caller ID information, remember this is dialed number, this is caller ID. So we're saying, does the caller ID match the answer address command? Looks under here and says, I don't even see an answer address command. You're done. So it says, does the caller ID match destination pattern? Well, it looks and says, okay, the caller ID 1101 comes in and matches, oh, look at this, matches the destination pattern. So it goes ding, 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 ding. We've got a match. We now have a match where we can say that I've matched dial peer 1101 inbound. Now you might be thinking, well, wait a second. If somebody calls 1101, so let's say this phone over here calls 1101 and it hop gets over to this one, isn't that the outbound dial peer? Well, sure it is. If we're going this direction, it's an outbound dial peer because we're going to make that phone ring, and that's the most specific match, 1101. We can use the same dial peer for inbound and outbound. It's just saying that I needed some kind of inbound match right there, and in this case, number 3 gave it to it. The caller ID matches the destination pattern. Now, how can I say this? There's a little catch to this scenario. When I say the caller ID matches the destination pattern, what gives this phone its caller ID? I mean, how does this phone know that it is 1101 coming in? The answer is it doesn't. An analog phone, I don't care how fancy the phone is, when you pull it out of the box and connect it up, that phone does not know its phone number. Your home phone right now does not know its own phone number. If you pick up, you get dial tone and you can make calls. And when you receive an incoming call, say your phone number at home is 555-1000. When you receive an incoming call from the PSTN, the phone, all it knows is it gets shocked. Remember, think back to the historical voice section. I said the phone just gets electrical signal on the wire and goes, whoa, and that's when your phone rings. So the phone actually doesn't know its caller ID information. So when I said ANI matches the destination pattern, in this case, that's not true. Because when the phone comes in, when we dial 2510, it comes in without any caller ID information. because the phone doesn't know what it is. Now, the router knows what phone number it is, but it sees that primarily as outgoing. So technically, that one doesn't match either. I was just showing that to you to give you kind of an example of how this inbound dial peer system works. So now take a look. We drop down to number 4. Call matches incoming port. Now, this call, as it comes in, we dial 2510. It came in on port 1/0/0. The router looks at its dial peer and says, okay, just port 1/0/0, we have a match. This is our real match. It came in on the port that dial peer voice 1101 had assigned to it. So for the incoming match right here, the router will use dial peer 1101. So we process that. Now it goes, okay, I need an outbound dial peer, and this one's easy. They dial 2510. I've got a match 2510 that says go to 10.1.1.2. So we send that over the IP network. This guy gets it on the other side. He now needs to match an incoming dial peer. So, again, he's going to go through his list. Let me clear all my little markings off here. Chump, 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 chump. All the way back up. If I have enough in my undo buffer, I do not. So he starts again from the beginning as he just received a call. Now let's chart out the stats for this call. The dialed number, or DNIS, that the call has is 2510, right? 2510. The caller ID that this call has that he received is 1101. And now it has caller ID information. Since it came from this router, it was able to tag what number it came from. So we've got called number and calling number information. First thing it does is say, does the dialed number, DNIS 2510, match some incoming called number on this? We look at the config, and the only config we have on router B says to reach 1101, that's going this way, to reach 1101, go to 10.1.1.1. So we have a dial peer allowing this phone to call 1101, and it will process and send to the other side. So in this case, there is no DNIS matching incoming called number command because there is no incoming called number command. So next thing it says, do we have caller ID or ANI information that matches the answer address command? Well, you look, and there is no answer address command, so that one doesn't match either. Now we say, does the caller ID match a destination pattern command? Oh, look at this. Caller ID is 1101, and it says destination pattern is 1101. Oh, we have a match, ladies and gentlemen. So this one, step 3 right here, matches and is acting as the inbound call leg for this guy. So now we have inbound because of the port, outbound because of the destination pattern, matching specific, so it's going out. As it comes in right here, this third step, ANI, matches the destination pattern, so that becomes the inbound call leg. Now, in all of this stuff that we've been talking about, what's the point? Sorry, I didn't mean to be so sudden on that, but what's the point of matching this? It seems like, okay, so you matched the one that's normally used for outgoing calls to 1101 as the ingoing call. Why do you do that? Well, because underneath here, we specify all of the settings for that. Now, this just shows destination pattern. It shows the session target. But, underneath the dial peer, when we get deeper into dial peers, you'll see things like we put quality of service values, like IP precedence values. We put DTMF relay, how it sends digits back and forth between these. We can put direct inward dial information. There's all kinds of information that we have under this dial peer. And what happens is as soon as it matches that, it applies all of this to the call. Whereas, let's imagine this. Let's say, get rid of all this stuff I have right here. Let's say we did not have this. Imagine this did not exist. Well, when this went out, and it would still have a dial peer, not shown here, that allowed this, we have a destination pattern, DP 2510. We would still have an outgoing dial peer to let this guy ring anytime a call came to 2510. Well, what would happen is inbound we would match, outbound we would match going to 2510. But on the inbound call leg, it would go through this whole list, say nope, nope, and it would come down here finally to this thing dial peer 0. And it would say, okay, well, I'll just use what's known as the default dial peer 0, or just allow you in using default settings so that you can complete the call. Well, dial peer 0 does not have any quality of service settings. So this call is going to be treated the same as data communication will be, which is potentially poor. It'll support any codec coming in, any voice codec. It does not support direct inward dial. So if this is a DID number, again, we haven't talked about all these things yet, but if that was a direct inward dial number, it would not support it. If it would not, let's see what else. VAD, voice activity detection, is automatically enabled on dial peer 0 and cannot be turned off. So if VAD was causing problems for you, it would cause problems on that call. There's a lot of settings on dial peer 0. Those are the big ones that take over, that just kind of go into a default mode setting. So the goal by having this inbound match is that we are able to specify all these settings. I was trying to get my scribbles gone here. We're able to specify all of these settings, the quality of service and all that kind of stuff, and we don't have to get down to this default dial peer 0 at the very bottom. So that is why we always have to remember the inbound dial peer. So that is where I'm going to leave the Understanding and Configuring Dial Peers Part 2 section. There is this section on digit manipulation, which I have decided, as I was talking, I was having this internal conversation with myself. I have decided to create my own nugget just for digit manipulation, because there's a lot of scenarios, a lot of discussions I want you to see, because digit manipulation is super important. We'll call it important flag 1.5 if we're looking at the little flag scenarios. So what we've done is now completed the wildcard discussion, talking about the dial peer wildcards, how we can create a PSTN numbering plan. And I would say the most important thing we grabbed out of this nugget is the outbound and inbound matching. Outbound matching being very simple, just saying the most specific destination pattern matches. Inbound dial peers going through that entire list of 5 steps to find the best one to match inbound. I hope this has been informative for you, and I'd like to thank you for viewing.